Alright, this page can be found under Files. I believe it's page 3. Right? What I'd like to do here is we're going to match these graphs with these equations just based on the end behavior. Okay, and matching that whether it's even or odd, positive or negative leading coefficients. So I know these equations are kind of small and maybe possibly blurry. I apologize for that. But I just want to go ahead and give you the first term. Okay, so this first term is positive x to the fourth. On B, we have a negative x cubed. On C, we have an x to the fifth. On D, we have a positive x to the sixth. On E, we have a negative x to the fifth. And on F, we have a negative x to the fourth. So we have 3 evens and 3 odds with different leading coefficients. Right? So this is a positive leading coefficient. And B is a negative leading coefficient. C is positive. D is positive. E is negative. And F is negative. So what I'd like to do is kind of match the end behavior. So on this first graph, we notice that both ends are the same. Right? So if the ends are the same, that means we have an even polynomial. And the fact that both ends are up means we have a positive leading coefficient. Right? So if you look at our possibilities of even polynomials with positive leading coefficients, A and D both fit that criteria. Right? So I'd like to go ahead and look at the graph across from it. Right? These end behaviors are the same. Okay, so since the end behavior is the same, I know it's even. Since they're both up, I know it's a positive leading coefficient. Okay, so these two are A and D. Now how do we tell the difference between A and D? X-intercepts or turning points. Right? So if we look here, this one has 1, 2, 3, 4 x-intercepts, 1, 2, 3 turning points, right? This one has 1, 2, 3, 4, 5. We'll talk about what it does when it touches in a minute. And then 1, 2, 3, 4, 5 turning points. So the one that has the more turning points is the higher degree, right? If it has 5 turning points, it has to be at least degree 6. This one has 3 turning points, so it's at least degree 4. So I'm going to conclude that the first one is equation A, and the second one is equation D. Okay. The one below it here, we notice that both the ends are going down. Okay. So first, they're the same, right? So the end behaviors are the same, therefore I know it's an even polynomial. The end behaviors are going down, so I know it's a negative leading coefficient. So negative and even, there's only one equation that's both negative and even, and that's this negative x to the fourth. So I know this one has to be F. Okay. All right, this one, the ends are opposite, right? One's up, one's down. So opposite means we must have an odd polynomial. Now, these ends, if I were to connect them, I would have a negative sloped line. So I'm going to say these ends are going down. And since these were starting up and going down, then I know it's a negative leading coefficient. Right? I'll match it in just a moment. The one next to it, okay, the ends are opposite again. One's down, one's up. So if the ends are opposite, I know it's an odd polynomial. Now if I were to connect these arrows, I'm going to start down and end up. So when I connect the arrows, that line has a positive slope. So I'm going to say this is going up, and therefore it's a positive leading coefficient. Right? The last one, again, the ends are opposite. One's up, one's down. right? So opposite means it's an odd polynomial. And the fact that from left to right, if I were to connect them, my arrows, are starting up and ending down, so this line here has a negative slope. So I'm going to say this is going down, which means it has a negative leading coefficient, right? So we have two odd negatives and one odd positive. So if we go up to the top, the odd positive should be easy to find. The odd polynomial with a positive leading coefficient is C. Okay. So we should have two negative odds, and we do. The two negative odds are B and E. One's an x cubed and one's an x to the fifth. So how do we tell the difference? Right? This graph here is a little funky. You see how the line kind of hugs here? I took the scaling off of here. And what happens here is there's actually a few more turning points than what it shows, right? So this one at the bottom here, 1, 2, 3, 4 turning points. Okay, this one only has 2, so this one must be the higher 5th degree polynomial, and this is the smaller 3rd degree polynomial. Okay, so that would make, let me zoom out here. That would make this one B and this one E. Okay. So even though in the equations we had lots of other terms, I just zeroed in on that first term, on the leading coefficient, and whether it was positive or negative, and we can match these to the graphs. Right? So I'm going to, at this point, kind of write down some notes. Actually, I think I'll just flash up the next page. Now, this is at page 4. This is going to be page 5 in the files. But what I'd like to do is really talk about a couple things here. Okay, first is this box is super important, right? The real zeros of polynomials. These are what I called the 4 equivalent statements. Okay, then the following are equivalent. Right, the first statement, C is a 0 of P. Okay, C is a 0 of the polynomial. Now that's might not be something you recognize the terminology yet, but you will. Right, because to say C is a 0 is the same thing as saying x equals C is a solution of the equation P of x equals 0. So if we were to set a polynomial equal to 0 and find all the solutions, C is a solution, C is a 0. Okay, they're the same things, right? Number 4, I'm going to skip down to number 4. That's the same thing as saying C is an x-intercept of the graph. So when we set the function equal to 0, we're really finding the x-intercepts. So the solutions are the same things as the x-intercepts, which is what we call a 0 of the polynomial. Now if C is a 0, here's number 3. We're going to use this a lot. Okay, then x minus C is a factor, right? So if I were to look at an equation here, or a graph rather, let's just say we had an intercept at -2, at -1, and at 2. Okay, say we had a graph that looked like this. So the graph is crossing at -2, it's crossing at -1, and it's crossing at 2. Okay, we have x-intercepts, -2, -1, and 2. That's the same thing as saying the zeros of this function are -2, -1, and 2. And if we had a polynomial to solve, these would be what x equals, right? These would be our solutions. So then what I'd like to do is practice writing those as factors, right? If -2 is a 0, then x minus -2 is a factor. So if we subtract -2, that's the same thing as adding. Okay, so x plus 2 is the factor. If -1 is a 0, okay, then x minus -1 is the factor, which changes that to a plus. And if 2 is a 0, then x minus 2 is the factor. Right? So when we solve our polynomials, usually we have a list of factors, and we'll solve these to get our solutions, and those solutions are our zeros or our x-intercepts. This is just going the other direction. We're given our zeros, and we're writing them as factors. Right? So this number 3 is actually really important. If you know where if c is an x-intercept, x minus c is the factor. If c is a solution, x minus c is the factor. If c is a 0, x minus c is the factor. Okay? So here is a polynomial. Okay, number 3, this is already all worked out. I'll just flash it up here and talk about it. This polynomial is already factored. Right? It factored to x plus 2, x minus 1, x minus 3. We already have the factors. So if I were to take this polynomial and set it equal to 0, okay, that's what I would need to do to find the solutions. Now if I have a set of 3 factors equal to 0, in order to solve those, I'm just going to take each factor and set it equal to 0. X plus 2 equals 0, x minus 1 equals 0, x minus 3 equals 0, and then we would solve these, right? We subtract 2 from both sides and get x equals negative 2, add 1 to both sides, get x equals 1, add 3 to both sides, get x equals 3. Okay, negative 2, 1, and 3 are the solutions, right? We have solutions, negative 2, 1, and 3. Well, those solutions are the same things as the x-intercepts. We have x-intercepts at negative 2, x-intercept at 1, and an x-intercept at 3. Okay. Now, if this graph wasn't already there, you would ask, well, how do you know whether it starts at the top and goes down or starts at the bottom and goes up? That's where the leading coefficient comes into play. Okay. If we were to multiply all this out, and I'm not going to do that, I'm just going to focus on the first term here. If I were to multiply x times x times x, that would be my highest degree term, and so my leading term is a positive x cubed. That means the end behavior is opposite and that it should be going up. Okay, so if it's going to be opposite, because it's odd, and going up, it's got to start down and end up. So I started down, okay, and crossed all those x-intercepts to where it's going up. Right? So kind of memorize this box up here, right? Know the difference between zeros, solutions, factors, intercepts, and then kind of apply that to graphing these polynomials. I have another very important topic to talk about in the next video, and then another worksheet that is going to really help you solidify what 3.2 is all about.